Okay, for this lesson, we are going to continue our work with negatives, positives and negatives, and specifically negative rates today. Maybe do some negative distance and negative time and throw that in there, but just to see some more situations where we might have negatives in our problems. So this is in the Signed Numbers packet, part 2, it's the brown one, and we're on page 26, so take a second to get there if you're not. And we are going to go down to this 12.2 right here. And we are going to start with that one, so pause when you need to, but we're going to get going. All right, it says water level in an aquarium. So this one's talking about a really large aquarium should contain 10,000 liters of water when it's filled correctly. Okay, 10,000 liters of water. So that's what we want to have in there. It will overflow if it gets up to 12,000 liters. That would be bad. The fish will get sick if it gets down to 4,000 liters. Okay, that would be bad too. The aquarium has an automatic system to help keep the correct water level. If the water level's too low, a faucet fills it up. Okay. If the water level's too high, a drain opens, so it would drain some water out of there. Awesome. So hopefully it's always kept at this 10,000 liters of water. It says one day the system stops working correctly. Yikes. The faucet starts to fill the aquarium at a rate of 30 liters per minute, and the drain opens at the same time, draining the water at a rate of 20 liters per minute. Okay, so let's figure out this situation. So we're assuming that it was starting with its 10,000 liters of water, that nothing was wrong with it, and all of a sudden faucets and drains start opening. So the faucet starts to fill the aquarium at a rate of 30 liters per minute. So the water is filling up at 30 liters per minute. Would we call that a positive 30 or a negative 30 if it's filling? Yeah, I would think if it's going up, that would be the perfect way to use a positive number. But at the same time, the water level is going down because a drain opened. So it's draining the water at 20 liters per minute. So if we've got 20 liters per minute, but it's going down, what kind of a number would we want to use there? Yeah, I would say negative 20. That's a good representation for filling or draining, positive versus negative. All right, let's see what the questions ask us. Is the water level rising or falling, and how do we know? All right, well, let's look at our comparison here. It's going up by 30 liters every minute, and in that same minute, it's going down by 20 liters. So in 1 minute, it's going up 30, and then it's going down 20. So what's kind of the overall change? It's going up 30, and then we're also adding a negative 20 to it. We're subtracting 20 or adding a negative 20 to it. What's the overall change? What are there more of, positives or negatives? There's more positives. By how many? 10. So it is really still staying at a positive, so it's filling at 10 liters per minute. That's the overall filling. So it is rising. Is it rising or falling? It's rising at 10 liters per minute. How do we know? Well, because there's more going in than there is going out. There's more water going in than going out. And we just proved that right here. We did the math to prove it. So how long will it take until the tank starts overflowing or the fish gets sick? Well, overflowing was if it was rising, the water level was rising, which we just said is happening. Fish getting sick happened when there wasn't enough water. So that can't happen because right now the water level is rising. So if we assume it started at its 10,000, how much more would it need to fill until it starts overflowing? It will overflow if it gets up to 12,000. So how many more liters would it need to fill? Well, we'd need 2,000 more. 2,000 more liters to get from 10,000 to 12,000, and then we've got trouble, and then it overflows. So to figure out how long it will take, how long is time? And as soon as I hear that, I know a time, and I know our rate. I know how fast this is filling. It makes me think of the distance formula, dirt, D equals RT. Even though filling up 2,000 liters, that's really a quantity. It's not really a distance. We can still use this idea of that change. So we want it to be, it would fill up by 2,000 liters. We want to know how fast that's going to fill. Well, how fast is it filling right now? What's the speed at which it's filling? Plus 10 liters per minute. And we just don't know the time it's going to take to get that far. So 2,000 equals 10 times something. So if you know in your head 10 times something to get to 2,000, great. We also know that whatever 10 times this is, it's also the same as 2,000 divided by 10. We can work backwards. 2,000 divided by 10. When you divide something by 10, it's just like taking off a zero. It gets 10 times smaller. So we'd end up with 200. So our time is 200 what? What's our unit of time that is in this problem? Is it seconds? Is it hours? The only thing we're talking about for time is minutes. So it's going to take us 200 minutes until it gets to that 12,000 liter mark where it's going to start to overflow. That would be bad news. So hopefully before 200 minutes they fix the problem and they can get that working again for those fish. All right, so this one gave us some examples really of adding positives and negatives right there, and then we did some more practice with the DIRT formula, distance equals rate times time, and we did a little bit of practice with division as well. Let's keep looking at another couple of examples. We're going to go to the next page, on to page 27, and we're going to not do the problem on the top, problem 2. You can skip that one. We're going to go to this one, 12.3, up and down with the Picards. So looking at this one, it gives us a new situation. It says Challenger Deep is the deepest known point in the ocean at 35,814 feet below sea level. Have you guys heard of this place? It's a place in the ocean. It's in the Pacific Ocean near Japan. And in 1960, these people, Jacques Picard and Don Walsh, rode down in this ship, the Triste, and became the first people to visit all the way down there, 35,000 feet below sea level. That's pretty amazing. So we've got a couple of questions. If sea level is represented by 0 feet, explain how you can represent the depth of a submarine descending from sea level to the bottom of Challenger Deep. Well, if you had this ship and all of a sudden it was going down and it was at this bottom point of the ocean, what would its depth be? Would it be a positive depth or a negative depth? We know it's going to be a negative, below sea level. We've talked about picturing above and below sea level before. So if it were really sitting way down there at the bottom, it would be a negative 35,814 feet. And we wouldn't have to say below sea level because that negative would represent that. And explaining how we know is that we can use negatives to represent below sea level. We know this. We've talked about this with fish swimming around below sea level. So let's see if we can do a mathematical question then about this, more than just knowing that it's at a negative distance below sea level. It says that this ship, the Triste's descent, was a change in depth of negative 3 feet per second. What does that look like to you? Negative 3 feet per second, that looks like a rate. That's its speed, negative 3 feet per second. If it's going at negative 3, what does that mean in this situation? It's going down, right? Negative 3 could mean possibly left or down because we're talking about a negative rate. So in this situation, it makes sense to be down. We can use this relationship. It says y equals negative 3x to model this, where y is the depth and x is the time in seconds. So y equals negative 3x, that looks really similar to me to d equals rt. We've talked about how distance equals rate times time is a proportional relationship, and so is this y equals kx. That negative 3 is just the constant of proportionality. It's the constant speed. It's the rate. So looking at this, we can think about it as y and x, or we can think about it as distance or the depth and the t, the time. So whichever one is more comfortable for you to be able to use. So it says, using this model, how much time would the Triste take to reach the bottom? Okay, I'm going to write it as d equals rt. What is that depth? We know how far the bottom is. It's this negative, crazy number, negative 35,814. That's how far down it would have to go. Do we know its rate? Yeah, we know the rate is negative 3 feet per second, so that's a negative 3. Do we know how long it would take? No, we don't know the time. So we have this equation now, negative 35,814 equals negative 3 times t. Now, I don't have that memorized, negative 3 times something to give me this. So I'm going to have to use my strategies of saying, well, the time is whatever this is divided by negative 3. Just going to write it over here for a minute. Negative 35,814 divided by negative 3 is going to be the time that it is taking for this to happen. So what do I know about dividing? A negative divided by a negative is going to be a positive. So we know that my time is going to be at least a positive number. And does that make sense? Because they're going down for a positive amount of time. So, okay. And what are my units going to be for time? What kind of time units are we using here? Looks like seconds, because the rate is feet per second. So some number of seconds we've got to figure out. Well, guys, we don't have calculators in our hands for this unit, so we get to practice some long division, and this one isn't going to be a bad number, but let's make sure that we could set this up and be able to do this by hand and see what this divided by 3 actually is. So we're in agreement, I think, that we can do negative divided by a negative is going to be a positive. We don't need to do any negatives in our long division, but we'd set it up like this. We'd do our 35,814 inside our division divided by 3. And let's practice long division and do this. How many times does 3 go into 3? It goes in once. 1 times 3 is 3. So I subtract that, and I bring down what's left, which is 0. And then I keep bringing down my numbers. So I'm bringing down a 5. How many times does 3 now go into 5? It goes in once. And 1 times 3 is 3. And I subtract it. 5 minus 3 is 2. And I keep bringing down the next number. How many times does 3 go into 28? Let's see, 3 times 9 is going to be 27, so I think that's as close as we can get. 3 times 9 is 27, and we're going to subtract that. 28 minus 27 is 1, and we're going to bring down our next number. This isn't hard multiplication, we're just bringing down a lot of numbers. How many times does 3 go into 11? Let's see, 3 times 3 is 9. I think that's the closest we can get. 3 times 3 is 9. Subtract 11 minus 9, and we get 2. And we're going to bring down our last number, which is 4. So 3 goes into 24 how many times? Hey, exactly 8 times. We don't even have to deal with decimals and bringing down zeros or anything, because 3 times 8 is 24. We get an exact number, and we're done. Whew. That is our answer. So what did that mean? I kind of liked how I put this here first just to fill in the blanks so I didn't forget what I was doing by the time I was done with all the long division. 11938, 11,938 seconds is how long it's going to take to actually descend that far. All right, I don't know about you guys, but I don't have a good sense of what that is right away. So let's just at least see if we can put that into a sense that we know what it is. So this could be an official answer, that's fine. But is that hours? Is that minutes? What are we looking at for that? Do you know how many seconds there are in an hour? How many seconds are there in a minute? 60 seconds in a minute, right? How many minutes in an hour? 60 minutes in an hour. So 60 times 60 is, 6 times 6 is 36, and add 2 zeros. This is how many seconds there are in 1 hour. 3,600 seconds in 1 hour. So this is definitely more than an hour. More than 2 hours? Yeah, 3,600 times 2 would be 7,200. You think it's more than 3 hours? What would this times 3 be? 3,000 times 3 would be 9,000, and 600 times 3 would be 180. So 10,800 would be 3 hours. So this is going to be definitely more than 3 hours. But it's not quite going to be 4 hours, because 3,000 times 4 would already be 12,000. So not quite 4. But definitely more than 3 hours. So they were descending straight down for 3 hours just to get to the deepest point in the ocean right there. At least we have a sense of that. So what we did in this problem was we were looking at negative depth, negative distance, and negative rate, and how when we divided those, we ended up with a positive amount of time. A negative divided by a negative gave us that positive time. And we did some long division practice along the way too. All right, we're going to continue our knowledge talking about depth in the ocean, and we are going to talk about a different submarine right now. We're going to skip ahead a couple of pages, really, to our last page of practice. So we are going all the way to, we're going to look at page 31. I'm going to look at 31, And we are going to look at number 5 on 31. So let's look at this guy. A submarine is only allowed to change its depth by rising toward the surface in 60-meter stages. So it must rise for 60 meters and then stop for a bit, and then rise for 60 meters and then stop for a bit. Why do you think that that is the case? Can you imagine a benefit to that? I suspect it's because the pressure is changing as you're rising to the surface so that your body can acclimate and get used to that pressure change as you're going down, which means that they must have been in a really cool submarine to be able to go down to go see that Challenger deep. They might have actually stopped and started a little bit more than it said on that last problem. So a submarine is, we talked about only allowed to change the depth by 60-meter stages. At what? Oh, it starts off, this is the part we need, at negative 340 meters. So it's starting, if I kind of drew a picture, here's 0, that's where we're trying to get to the surface. It's starting at negative 340, and I'm kind of guessing where that is down there. So at what depth is it after one stage? So after it rises 60 meters, aren't we just doing negative 340 plus 60 more? Negative 340 plus 60. Is it still going to be in the negatives? Yeah, absolutely, because we're still below 0. We're still below ocean level or water level. So how much more below? Well, we know it's negative. And now when one's positive and one's negative, we still just subtract them in our heads. So 340 minus 60, well, we'd take away 40 to get to 300, and another 20 would be negative 280. And what's our depth? Meters. That's where we would be after one stage. So going up 60, we would still be at negative 280. Right there. All right, after 2 stages, if we go up one more time. So really what we could do is we could say negative 340 plus, and after 2 stages, isn't that 2 60 stages? 2 60-meter stages? What is 2 times 60? That's going to be 120. So we're adding 120 meters to it. Now, could we start at 340 and do that? Or could we also just start at negative 280 and add another 60 to that one? Absolutely. It would work both ways. Here, I know it's still negative, and I'm going to subtract these in my head. 300 minus 100 is going to be 200, and 40 minus 20 is 20. Negative 220 meters. Some of you would have just started here and added another 60 to that. Right? After 4 stages, I'm thinking, I'm just going to do the work down here. What if I just still started at the beginning, negative 340, and I'm going to add 4 stages to it. 4 stages times 60 each stage, because I'm going up. 4 times 6 is 24, so I'm really just adding 240 meters to it. Still negative. There's more negatives than positives, but when I subtract them, I get a nice 100. So it's still at negative 100 meters right there. So last question, how many stages will it take to return all the way to the surface? Well, how many times am I going to have to go up 60 meters? Basically, we're saying how many 60s fit into my starting depth, negative 340. So negative 340 divided by 60 right here, and actually we can think about it as the positives right there. We don't even have to think about positive or negative because I'm just saying how many 60s fit into 340. Right? How could we divide that and see? Can we do some long division? I think you guys can. First of all, could I make this a little bit simpler and say I want to simplify this fraction? Could I divide them both by 10? Really, I'm asking what's 34 divided by 6? So if I did long division, how many times does 6 go into 34? Oh, actually, this isn't really long division anymore. We're really looking at just how many times does it go in? 5 times. 5 times 6 is 30. We bring down the subtract and we bring down a 4. And then we run out of numbers to bring down. So the long division does come into play when we need to add a decimal point. We didn't get to practice this last time. If I need another number to bring down, 34 is the same as 34.0. So I'm going to add a 0 and then bring it down. How many times does 6 go into 40? 6 times, what would it be? 6 times 6 is 36. I don't think we can get closer to that. And I'm subtracting that and I get 4 again. Well, if I need to bring another number down, I can add another 0. Hey, 6 goes into 40 how many times? 6 again. I'm seeing a pattern. I think we're just going to repeat with the 40s here. So this 6 is going to repeat forever. 6, 6, 6, 6, 6. 5.6 repeating. I could even put the repeating on this one right here. 5.6 repeating what? What were we answering? How many stages? Well, we probably can't have 5.6 stages. So at 5 stages, it won't quite be to the surface, and then they're going to be able to rise up a little bit more right there. Right, so that just gave us some more division practice and some more practice with adding with the positives and negatives. All right, so I am going to have you guys work on the next part of the lesson right now. You guys will know what you need to be doing, and I will see you later on.